Okay, 68. Looks like the answer is 5 meters. Now, I haven't done these problems, so this is my goal. I'm going to try to get the right answers, just like you guys. 68. It says trained dolphins are capable of a vertical leap of 7 meters straight up from the surface of the water, an impressive feat. So, I'm already thinking that I'm probably going to be looking for an initial velocity here, and then use that velocity at some other time. So we know this is 7 meters. It says, suppose you could train a dolphin to launch itself out of the water at this same speed. Okay, good. So I'm going to need to find that. Now, I know if that's the highest he can reach, then this velocity up here must be 0 meters per second. Just basic free fall knowledge. We're going to launch it at an angle. It says, what maximum horizontal range could the dolphin achieve? Now, for this, to get a maximum displacement, we have to know that that occurs when my angle is 45 degrees. So that's good. Now the problem is asking us, okay, if we know this velocity and we end up shooting it at 45 degrees, shooting the dolphin jumps out of the water at 45 degrees at this same velocity, then how far will it go? That's the ultimate question. Okay, well, let's get started. I'm going to go ahead by finding this velocity. And to do that, looks like I have VF, I need VI, I have a delta X, I know acceleration is negative 9.8. That should be ringing a bell for you to use the VF squared equation. So I'm going to say 0 squared, my final velocity, equals my initial velocity squared, which is what I'm looking for, plus 2 times negative 9.8 times delta X. Or in this case, we're just talking about a vertical distance, delta Y, of positive 7 meters. Now, this should give us a positive VI. So I'm doing, in my calculator, I'm going to do 2 times negative 9.8 times 7. Okay, if I take that to the other side, it's positive, so 137.2 is what I need to take the square root of. And that will give me my VI. So VI equals 11.7 meters per second. Now, if I know this is 11.7 meters per second, I'm going to go ahead and find VIY and VIX, or VX, because it stays constant. Now, if I know VIY, then I can use the fact that, okay, we're leaving the water and hitting the water again at the same vertical distance, so delta Y will be 0. I can use that fact to solve for time using VIY, and once I find the time, I use delta X equals VXT to solve for delta X. So let's go ahead and solve for T. 0 equals VIY. VIY is 11.7 times the sine of 45 degrees. Okay, that right there is my VIY times T plus 1/2 AT squared. So plus 1/2 negative 9.8 T squared. If I solve this for T, I'm going to go ahead and do that. I'm going to do 11.7 times the sine of 45. And I get 8.27. So 0 equals 8.27 T minus 4.9 T squared. So take this to the other side, you get 4.9 T squared equals 8.27 T. This T cancels with one of those. Divide by 4.9. Remember, if your calculator has the solve function, then you can just basically type all of that in, tell your calculator to solve it for t or x, whatever variable you're using entering it, and you'll get the right answer. So we get t equals 8.27 divided by 4.9, 1.69 looks like, 1.69. And now delta x equals Vx times t. Now I know Vx is going to be 11.7 times the cosine of 45 degrees. So this right here is Vx. Don't get confused because I'm just putting it in my equation. And then time we found to be 1.69 seconds. So now delta x equals hopefully 5 meters because that's what I'm going for. 11.7 times the cosine of 45 times 1.69. No, what have I done? Okay, well, the answer is 13.96 or 14 meters. And that's not the 5 meters I was aiming for. I just went back and looked at the book's answers, and you see they use an equation. They use this equation that somewhere in the book they derived. I didn't teach you to derive this equation because it's not important, and it's not an equation you're going to ever memorize. So it's much easier. In some cases, it's easier doing it the long way because that's the way you know that's the equations you're used to. You guys don't like derivations anyways, but if you can see, they're using this equation, and they say it simplifies to this right here, VI squared, and then they use this 7 meters, which is completely wrong, because 7 meters isn't a velocity at all. And when I used this equation and plugged in the 11.7, which is what we found for VI, and 45 degrees here and here, and 9.8 for G, then I got the 14 meters. So we're going to cross out this 5 meters, say the book is wrong, and the correct answer is 14 meters. Sorry for the confusion.